All right, guys, look. Last time when we were recording, what happened was we got cut off, right? But this is what we're looking at. Use the compound angle identities to simplify each expression, all right? So let's check what examples we've got. All right. Okay. Right. So the first question that we have is as follows: the cosine of 2a times the cosine of a, okay, minus the sine of 2a, and then times the sine of a. Now, if we're going to use the compound angle identities to simplify this, that means we now need to rewrite this as a compound angle. In other words, it has to be either sine of one angle plus another angle, or cosine of one angle plus another angle. You guys get what I mean. So something like that. So look, you can see that we've got homogeneous trig ratios. I try not to use the word homogeneous, but I just end up using it. But anyway, you can see that we've got the same trig ratios here. So cos, sin, okay? And I hope you can already, see that this is a compound angle for cosine, okay? So meaning that we're going to have cosine of some two angles, we don't know whether they are being subtracted or they're being added, okay? But what we do know is that if it's a minus over there, it's going to be a plus as long as we're dealing with cos. So now there's two angles that we're dealing with. I mean, it's easy to identify the angles. 2a and a, 2a and a. So 2a here, a over there. What is 2a plus a? I hope you said 3a. All right? Yeah. Now let's look at the second question. So we've got the sine of 2a times the cosine of a. Immediately when we've got trig ratios that are different, right, you already know what type of compound angle that is, okay, times the sine of a. Okay, so trig ratios are different. Remember when we said trig ratios are the same, we said we're dealing with cos. Now they're different because there's only two trig ratios that we're talking about right now. So that's going to be sine. Okay, now sine, remember with the trig ratio sine, if there's plus in the middle, there's also going to be plus there. The signs don't alternate, okay, they're exactly the same. So cool. Now what angles are we going to plug in over there? Okay, it's just going to be the two angles, 2a and a. So 2a and a. So now what do we have? We've got the sine of 3a, right? Easy, isn't it? Now let's look at a slightly different problem, and with some numerical values. So sine of 50 degrees, okay, times the cosine of 10 degrees minus the cosine of 50 degrees times the sine of 10 degrees. Okay, so Your job is this: check, do we have here and there, do we have the same trig ratios or different trig ratios? If the trig ratios are the same, then we know the compound angle is cosine. If the trig ratios are different, the compound angle is going to be what? Sine. You can see that here it's sine and there it's cosine. So the trig ratios are different. So the compound angle is going to be what? Sine. Okay? And if the compound angle is sine, you know for sure that the sign in the middle here, it's not going to alternate. It's going to be exactly like that. Okay, now we've got to plug in the two angles. We've got 50 and 10, so 50 degrees, 10 degrees. Now what's 50 minus 10? 50 minus 10, the sine of what? 40 degrees. In the exam, I wouldn't try to figure it out, from the top of my head. I'd use a calculator, Yeah, you guys don't know things that happen in the exam. Y'all don't know, because you just become so nervous and then all of a sudden 1 plus 1 is now 3. So you gotta be careful. You gotta act stupid when you're in the exam. Okay, I always tell this to my learners. Hey, be careful. Okay. Another problem. So the cosine of 70 degrees multiplied by the sine of 30 degrees minus the sine of 70 degrees, okay, times what? The cosine of 30 degrees. Even if there's no dot over there, the assumption is that that is multiplication. The same way you've got 2x without the indication of the multiplication sign, right, 2x without the indication of the multiplication sign there, in between. So when you write your 2x, you don't put the dot in between, but the assumption is what? That there is, the 2 are actually glued by multiplication. That's the assumption. So even in this case, if there's no dot over there, assume that there is multiplication happening. But anyway, let's try to simplify this. Remember what I said, you focus on the two trig ratios, whether they're different or they're the same. And it looks like they're different. And if they're different, the compound angle is going to be what? Sine. Now, if it's sine, the angle in the middle, we're not alternating anything, it's just going to be minus. What are the two angles? We've got 70 degrees. And what else do we have? 30 degrees. Now, what's the difference? 70 minus 30, use your calculator. Remember what I said? The sine of 40 degrees. Okay. So, there you have it, ladies and gentlemen. We have simplified that, complicated looking expression. So, we are going to look at, slightly different problems. So now they're saying evaluate without the use of a calculator. Evaluate without the use of a calculator. Without the use of a calculator. Okay. All right. There you have it. That's the question. Now, let's see what we're given. So we're given a. We've got the sine of 40 degrees, and I mean, whenever you're dealing with trigonometry and they say without the use of a calculator, I mean, chances are that you're going to deal with special angles, okay? And you must be really comfortable with that, because that's like things that you guys covered in grade 10 and in grade 11. I mean, 2 years, that's a lot of time. Okay, the cosine of 40 degrees and the sine of 20 degrees. I mean, if you've got two pairs of products like this, you must be already thinking, okay, chances are that the first thing that I gotta do is to, you know, sort of like congest the two using the compound angle and identities, right? So you can see that this looks familiar. You know, we've just covered this. We've got sine, cos. The trig ratios are different, so the compound angle is going to be sine. And whenever you're dealing with sine, the mode of sine is not alternating, it's just the same. So we've got 40 degrees over there, we've got 20 degrees over there, and then what does this become? The sine of 60 degrees. Now, how do we figure out the sine of 60 degrees without using a calculator? Remember, there's this triangle. These are the triangles that you guys need to remember, okay? So there's 60 degrees over there, there's 30 degrees over there, and then there's 90 there. So what I do know is that the sine of 30 is 1 over 2. So this is 1, this is 2. Remember, sine is opposite of hypotenuse. It's 1 over 2. You can even use your calculator, okay? So you can cheat a little bit. You're going to say, only when you're constructing triangles, you're going to say, okay, the sine of 30 degrees, it's 1 over 2. So remember, the one on top is the opposite side, and the one in the denominator is the hypotenuse, okay? So it's the hypotenuse. So you plug them in onto the triangle, and then now 60 degrees, okay, 60 degrees. You can say sine of 60 there. 60, it says root 3 over 2, okay? So the root 3 is the adjacent side. Not that it's the adjacent side, it's still the opposite side, just that we need to look at it this way. Yes, the sine of the angle 60, if this is our angle of reference, right, if this is our angle of reference, 60, so where's the root 3 going to be located? So root 3 is the opposite side relative to this, okay? I'm just trying to figure something out. Okay, sine of 60 degrees. Okay, seems like I was supposed to. So remember when we did sine 30, so this is the 30 degrees angle, so the opposite side needs to be here, okay? The opposite side for this 30 degrees angle. So now we know opposite over hypotenuse, yes. And then now the sine of 60, the opposite side is root 3. The side that is opposite to 60 degrees, that's root 3. And it says the hypotenuse is 2, so the hypotenuse kind of like, you know, coincides. Cool. So this is the first angle that is kind of common. Now I want us to draw another angle, triangle, that is also a little bit common, which is the 45 degrees triangle. So 45 degrees, 45 degrees. This is easy to remember because it's 1 over 2, so it's 1 here, and then root 2 there. So 1, 1, 1, root 2. In case you forget, you can just say, okay, sine of 45. Then you know that, okay, the whatever that's in the numerator is going to be what? So in fact, this one has been rationalized, so you can multiply by root 2 over root 2. So yes, this is the same as 1 over root 2, right? What you're seeing over here, root 2 over 2 is the same as 1 over root 2, okay? So meaning that the opposite side is 1 and the hypotenuse is root 2, okay? So if you use cosine, you will realize that still the adjacent side also is going to be 1, because cosine of 45 and sine of 45, they're exactly the same. You see, it gives me root 2 over 2, which is the same as 1 over root 2. Okay, so there you have it. I mean, that's literally how I draw these things. And once you've drawn these triangles, you can literally figure anything out. Whatever special angle that you're given, you're going to be able to, find its value. So the sine of 60 degrees, you go to the triangle which has got 60 degrees. Okay, so 60 degrees, there you have it. Now sine, according to Sakato, what does it say? Opposite of our hypotenuse. So relative to this angle over here, relative to this angle, the 60 degrees angle, the opposite side is what? Root 3. So that's root 3, and the hypotenuse is 2. And the problem is done. So let's look at another problem. 40. Okay. The second problem is as follows. We've got cosine of 40 degrees, sine of no, it's cosine of 20 degrees. Again, you can already predict what the compound angle is going to look like. We've got, same trig ratios. So sine 40 degrees and sine 20 degrees. If the trig ratios are identical, what compound angle are we going to have? I hope you said cosine. So also, if it's cosine, you know that sines are going to alternate. If there's a negative there, then we're going to have a plus over there. And then the two angles, we've got 40 degrees and 20 degrees. And we've got the cosine of 60 degrees. Now we go back to the 60 degrees triangle. Now, what is cosine of 60? According to Sakato, what is cosine? Adjacent over what? So adjacent side, that's 1. Hypotenuse, that's 2. Everyone happy? C. So let's look at another problem. We're given cosine of 75 degrees, cosine of 15 degrees. Again, the trig ratios are the same. Right, I already gave you guys a clue. Trig ratios are the same. So what's the compound angle going to look like? Cosine. The middle sign is positive, so we're going to have a negative over there. For as long as we're dealing with cosine, signs, the middle signs will always, alternate. So cool, the two angles that we're dealing with, we've got 75 degrees here, we've got 15 degrees over there. What's 75 minus 15? Cosine of 60 degrees. That's just 1 over 2. Okay. Last one. Let's look at the last one. Alright, let's look at the last one. And then that will be it for this lesson, ladies and gentlemen. We've come a long way. It's actually been a long day for me today because I've just had some technical issues, with the camera and all that. But we're here, you know what I mean. So last question. That's okay. I want to see something. So sine 70 degrees, cosine of 25 degrees, and minus the sine of 20 degrees, and lastly the sine of 25 degrees. Okay. So this one, you can see that the angles are not the same. So it's 70 degrees over there, here it's 20 degrees. Alright, so it's a bit complicated. It's not like the usual type of question, but what I can say is that we can work on it. Okay, I was about to say there's no solution, but as when I look at it, I realize that hey, we can actually work this one out. So yeah, so we just need to change this to cosine 70. So remember, we're using the co-function ratio, so sine 20 degrees is the same as the cosine of 90 degrees minus the 20 degrees, which then gives us what? The cosine of 70 degrees. Okay, so we can rewrite this, right? So that becomes what? The sine of 70 degrees cosine of 25 degrees. Fine. And then minus what? The cosine of 70 degrees and the sine of 25 degrees. Okay, so we shrink this using the compound angle additive. You can see that we've got different, we've got different trig ratios, so that's definitely sine. And then with sine, whatever middle sine that we're having over there, we're just going to copy it. So cool. So now what are the two angles that we have? We've got 70 and 25 degrees. Now this gives us the sine of what? I hope that it's not what I'm thinking. Let's see, it's 70 minus 25, that's 45 degrees. Now what is the sine of 45 degrees? Remember, 45 degrees is within this triangle over here. You see that triangle over here? Yes. So we focus on, we can focus on either side, that side or this side. It's not going to make that much of a difference. But relative to this angle over here, what is sine? Remember, according to SOHCAHTOA, what you guys did in grade 10 and 11. So sine is opposite of hypotenuse, so the opposite side is this, the hypotenuse is √2. So sine 45 degrees is equal to 1 over √2. And that's that, ladies and gentlemen. We are done. All right, finally. And if you watched this far, congratulations, congratulations. And don't forget to like and subscribe, and also share with other people that you think might need might find value in this video. But without wasting too much of your time, let me sign off. Shout out.